This is Maker Galaxy.
We're always talking about the future of design, the future of technology, the future of making. In a world where ready-to-wear clothes can be digitally fabricated in a user's home. A world where 3D mapping smartphones will track our surrounding environments. How do we find the next big thing? Maker Galaxy is a show that explores the crossroads of design, technology, and the future of making. Welcome to the show, everybody. I'm your host, Simon Martin, and this week we talked with inventor and all-around cool guy, Greg Mark, CEO and founder of Markforged 3D printers. Now, 3D printers are popping up left and right these days. However, Greg has brought his knowledge of working with carbon fiber to bring us the world's first carbon fiber 3D printer. We'll talk with Greg about everything from how he assembled a world-class team to how he thinks the product will be used. Today's episode is brought to you by the new Objet 500 Connects 3 from Stratasys, the world's only color and multi-material 3D printer. Offering incomparably brilliant and consistent colors, plus transparent colors, the Objet 500 Connects 3 lets you create the most true-to-life modeling possible. Find out more at stratasys.com. Welcome, Greg. We'll get into Markforged in a minute, but before we do, we want to know, where can we find the best sandwich on earth?
All-Star Sandwich Bar in Inman Square. Freaking awesome. We've taken some of the outer towners there, and it's to die for.
So what all's in it?
Oh, dude, they have these specials. So like every day you go in there, there's like a rotating list of specials.
Okay.
So they'll be like, they got like the turkey sandwich, they got like the veggie special, they got like the extra funky rotates, and it is awesome.
Awesome. Well, listeners should take note of that place then. So, Greg, let's start from the beginning. Before you were designing 3D printers, you were an aerospace engineer. Tell us a bit about your path towards becoming an aerospace engineer.
Oh, good question. So, I guess I did undergrad and a master's at MIT in aerospace engineering, which will pretty well set you up to go on to do that. Prior to that, I used to make bicycle frames when I was in high school. I got lucky enough to work at a shop in Rockville, Maryland they used to make custom bicycle frames, aluminum, titanium, steel. So I learned how to do all that stuff at a young age. And MIT was just, when the aeroastrophy department at MIT is like really, really awesome.
So tell me more about your experience at MIT. I mean, what time frame are we talking about? Were you at MIT?
I got there in 99, finished the undergrad in 03, and did the master's through 05. And actually, the master's was cool because we made this autonomous helicopter. So we took this like super, this high-end carbon fiber like remote control helicopter, and then we built a control unit that sat on it that ran like, it's essentially what your iPhone does now, but before the iPhone existed. So it was really expensive and time-consuming, but it had a full inertial navigation suite on it. So we basically turned it into a drone, but unlike these kind of like slow, clunky-looking drones, this thing would do angular rates of like 300 degrees a second. So it would do all these. There's actually some videos online, edited by me, so they're not like kind of amazing quality, shot in 240p back when that was the shit. And but you can see these things like flipping over, doing barrel rolls, doing hammerheads. It's pretty cool.
Awesome. So this was kind of this was about the time where the Media Lab was picking up, right?
Yes, absolutely.
And so were you a part of the Media Lab at all when you were there?
No, this was all through aerospace.
Okay, so no 3D printing exposure for the most part.
The first 3D printer I ever saw was when they actually renovated the aerospace department in 2000, and they got one of the early Z-Corp printers, like serial number 6.
Okay.
And that Z-Corp technology was invented at MIT, and then actually was licensed by Marine and a few other people, and they make it's really great for conceptual, but it's not a structural part.
Right.
Right. So it's so my first experience with 3D printing was it would be really great from a aesthetic and design side, but I didn't know FDM at the time.
How did being an aerospace engineer, well, first of all, where did you go after college?
So my first job after college, I worked for a startup out of MIT called Trivertech that made really high power connectors. So connectors is like, a plug that AMD would use to test their new chips, right? So they make a whole bunch of chips in order to burn in and qualify them before they, stick it into your computer, solder it to the motherboard, and forever like lock it in. They want to do a whole bunch of test and burn in.
Right.
And we made these really high-end connectors that they used to do that testing.
Awesome.
That company got sold in 2008, and I was like 26, 27. I just spent like 3 years in making plugs, and I wanted to do something in aerospace. So with a friend, we founded AeroMotions, which was that computer-controlled race car company.
Oh, nice.
So we made like these computer-controlled racing wings, which kind of went back to the whole like autonomous helicopter thing. So the wings were all carbon fiber. The deluxe wing. The website's really cool. The deluxe wing is like $9,500. It weighs like 12 pounds, and if you bolt it on the back of your car, it'll take 2 seconds off a 2-minute lap. It's pretty sexy.
Wow. And so, how did this lead into creating a 3D printer?
So in AeroMotions, everything was composite, right? So we got the baseline familiarity with how fibers move, how resin impregnates through fibers. We built up that intuition of both the intuition of how the materials would work and the understanding of the need. So the largest and the most expensive component of the wing is the airfoil itself. Every other part in the wing is aluminum. And the thing about aluminum is you can buy that part for you can design a part, you can specify it to get machined, and you can buy it from any number of thousands of different people, right? And ramping
Right.
volume or lead time. This is a really well-known art. Carbon fiber, at least in the traditional capacity, it's as far as materials that we use, it's the highest strength to weight ratio. I mean, there's some things like engineers sometimes, some of the guys here say, there are certain small things you can carbon nanotubes that you can make at lab scale, but nobody uses. And there's never fighter jets made out of carbon nanotubes. So among materials that we use, carbon fiber is like the top of the list. The problem with it is it's a bear to make. There's a whole lot of hand layup in the process, even for super advanced things like the blades on GE aircraft engines. Like, talk about one of the most advanced shapes in the world. I mean, those guys know how to design beautiful aero stuff. It's all the sections of carbon, and there are like hundreds of them, are laid in a mold by hand, right? And then you have to go through the vacuum bagging step. You have to trim it. It's just, that race car wing, we have to mold a bottom skin, mold a top skin, make a wing spar, glue them together, trim them. It's a very time-consuming process, and there's a lot of hand labor. So there was kind of this need to, there's recognition that composites are, enable, phenomenal strength to weight ratio, but they're just in the traditional processing capacity, they're very hard to make.
Okay.
Right. So what we did is we used the mechanics of a 3D printer to automate that fiber layup process.
How did you start tinkering and putting together the components of a 3D printer? I mean, are these pieces you pulled off of other machines and then kind of figured out a way how to get the carbon fiber in there? I mean, how did you start actually designing the 3D printer?
Great question. So we, on the FDM side, which is this whole open source movement on 3D printers, which brought about MakerBot, brought about Ultimaker, brought about all these kind of pieced together desktop models.
More specifically, like the RepRap, or
yeah, so exactly the RepRap project. So that idea enabled us. The first versions of this we use an Ultimaker, right? So we use the same way when McLaren built the F1, right? They started this super exotic car back when I was a kid.
Yeah.
When they built the F1, they took Ultima GTRs as a body, and then they started modifying them, right?
Right.
We did the exact same thing. We took the framework, which was this Ultimaker and this open source stuff, and then we built our own print head, and we started that way. In parallel, we ran the project to actually design a machine that would be a lot more robust and repeatable which is what you saw at SolidWorks World. But in order to get up and running fast, you try to, if you want to get to market as quickly as possible, which is always a good way to go in a fast moving space, you need to take advantage of as much off the shelf stuff as you can.
Definitely. And so what about in terms of the software side of things, how did that come out to play?
Really good question. So actually the first guy we hired, David Benheim, is a software guy straight out of MIT, really, really clever guy. And the first thing he did was take this open source software, look at how the slicing's going. We have a unique problem in the fact that we have this continuous fiber, so we have to run the path planning differently than other people did. At the same time, David's a really high-end computer science guy, so a lot of the open source stuff is good, but it's kind of like pieced together by a lot of different contributors with a lot of different skill levels. So he kind of looked at it for inspiration and then rewrote his own. So we have a unique slicer and a unique front end and a unique back end. It was inspired, and we learned a lot from the open source stuff, but we couldn't trust the reliability of it.
Good answer. So tell us more specifically about the Mark I, your first 3D printer. All of this tinkering, bringing in some of the best people in the industry to join your team. It all came together in the Mark I. So what is the Mark I for listeners who know nothing about the Mark I 3D printer?
So it's the world's first 3D printer that can print composites. So those composites are carbon fiber, fiberglass. It's essentially fiber reinforced plastic. So what you and I, or what the layman would call carbon fiber, extended out as carbon fiber reinforced plastic, CFRP.
Okay.
Right. So it's essentially like a traditional 3D printer that you would know and love, but instead of just shooting plastic or just printing in plastic, we reinforce that plastic with these long, continuous strands of carbon or fiberglass or both, which gives you 5 times the strength and 20 times the stiffness. And if it's literally the difference between picking up a 3D printed part that feels like plastic versus one that feels like metal.
Right.
So where we are today with the technology, our carbon fiber has a higher strength to weight ratio than 6061 T6 aluminum, which is like, it's aerospace grade aluminum. It's totally awesome. So you pick up this part out of a 3D printer, it has the weight of plastic. You would expect it to be plastic. Then you go to bend it, and it just doesn't move. Right? So there's this visceral reaction. It's like, wow, this is like amazingly strong.
It's obviously strong, but it differs from traditional composite layups that are limited to a 2-dimensional layer of fiber. So how are you working around these constrictions?
So we do. So you think of it like 2.5D, and it's interesting. If you look at that race car wing that we have, it is a 2D profile. So you could print that type of profile on the machine now, right? So most beams, most things that you do, so you can get the curvatures and the shapes that you need for the front and the back of the wing, right? But while printing it building it up in this 2D way.
Gotcha.
It's kind of hard to do with audio only and no visuals, but
it's like a boat frame.
Yeah. So your boat frame, for example, you would print it upside down. So you would start by printing the widest part first, so that way you build inward to the keel. And if your boat frame, the loads that it has to support are in bending, right? So you have a fuel tank, you have all these waves, picking the boat up, rocking the boat. Those are substantially bending loads, and having fibers running front to back along the boat is exactly what you want.
Gotcha. And so what are some other existing, or perhaps not existing, but other applications that you see for this besides a race car wing?
So there's been a big interest on the side of prosthetics, right? And when you look at these prosthetics, some of these are, there's some of these are things that people in the medical device side, things that you want to implant in the body. Others are things that artificial limbs that you want to use to replace limbs that you may have lost or people may have lost. And it's great from that design perspective because it's a 2-headed printer. So you have that normal plastic side, and we print nylon, nylon's an awesome material. Like you cook with it. It's high temp material. It's not the highest, but it's very high. It's super safe. It's inert. You cook with it. You eat off it. Like nylon's implant, medical grades of nylon are implantable in the body.
Right.
It's like when you print it, it doesn't stink. It's a really, really great plastic. It also has the value of being low friction, so it's a nice wear surface. So we have that standard like nylon printing head. So if you're building this, this prosthetic arm or this prosthetic leg, you can run through. It's part science and part art, right? Like you need it to fit onto a human body. This is a very organic shape. You want to try out a few different prototypes, right? Until the wearer or the user of this prosthetic finds a shape that fits well, right? Then once you have that shape that fits well, you reprint the part, now adding composite in it, and the part's very strong, right? But then that part is done. I mean, you prototyped it on the pure nylon head, and then when you wanted to reinforce it and make it so the part that the customer will actually wear and use to go about their life, you add the composite.
Okay, so in terms of the flexibility of where I would want to put the carbon fiber in my part, like let's say I'm doing a stress analysis test and I notice a hazardous red area, so I can pinpoint that area from my simulation and have that entire cavity be filled with carbon fiber, and then the entire rest of the part no carbon fiber. I mean, is it that flexible for figuring out where I want to add this second material in the part?
Okay, so right now, it's a very good question. Right now we have two modes in the software. There's an automatic mode where you will drag and drop a part inside of it and give it like high level parameters, like I want it to be all nylon, or I want it to be like 20% carbon, and it will strategically put composite in the generally most advantageous places. Now let's say that you're an aerospace guy and you really want to push the envelope on this thing. You can go in layer by layer and say, oh, you know what? I want this. You can say, like in that race car part, we said, okay, these middle layers, we want them to be honeycomb fill because they're great at transferring what's called the shear loads. But the top layers, we want to have 3 layers of carbon on top and 3 on the bottom. If you decide you want that part to be a little stronger, you can take you can swap those, you can increase that, the number of carbon layers on the top or the bottom. You can either do that globally with a slider, or you can go in manually like layer by layer and say, I want to use this fill pattern, I want to have this layer be plastic, I want to have this layer be carbon. It gives you, it has that automatic mode for people who are new to this or who just want to like crank out a few quick parts. But then it has that like really fine detail mode. You can go to the other end of the spectrum for people who really want to dial in, like you said, that stress concentration. You know that you need complete carbon fill in this area. You can dial that in.
You had your big reveal at SolidWorks World 2014 with a very positive response from the SolidWorks audience in attendance. How did it feel to finally get this concept out there, and would you have done anything differently?
It was great, and you could see it on the look of, we've got a great team working on this thing, and I'm paranoid by nature, as a lot of entrepreneurs are. So we have a strict, first rule about Markforged is you don't talk about it policy. And so for these guys who've had to be very quiet about this, to finally get to go interact with a whole bunch of engineers and get to explain the machine, and everybody was there presenting this thing that they're very proud of, that they've worked on very hard for a long period of time. It was very rewarding, it was the guys had a great time, and the nice thing about the SolidWorks community is, there's a lot of clever people, right? So you show them this printer and you show them what it can do, and they get it. And that was one of the things that we didn't know was, when you talk to a composites person, they're going to get it immediately. But even the people who are used to aluminum and used to, have not done a whole bunch with composites, they see the printer, they see how it prints, and they get it like immediately. It's very nice to be selling to a set of people, making a product that when a customer sees it, they know how to use it, and they're excited to use it, right? Like the number one question we got was, when can I get one, right? So it was really nice. It's nice to work on something that people care about and people can't wait to use, and that people can, everybody came up to us and they wasn't like, oh, what am I going to use this thing for? They were like, oh wow, if I had that X time ago, I would have made this part for this machine out of it. I would have made this thing for it. Like, it's just people immediately started thinking about what they could do with it and like how they would use it. It's really cool.
Okay, and so any advice for people wanting to build their own 3D printers, or even advice about launching a product for that matter?
On the build your own 3D printer, if you want to do it, on the one hand, it makes you a competitor, so plus minus. But my quick advice on that would be do it fast, because this is a closing window, right? I mean, MakerBot basically, you look at MakerBot, the timing was perfect. They took an open source idea, they sold it to you from one place, and it's what's the amazing part about that. I remember when they first came out, I was building race car wings, and you had no idea how successful they were going to be.
Yeah.
Right. And then once their success was shown, like they had there's a new copycat or new, slightly different MakerBot that comes out every couple of weeks on Kickstarter.
Yeah.
Right. The time to do that window is closing. Right. So we think that we snuck in when the window was still open. We have a unique product, so it makes it a little bit easier. But if you have a brilliant idea for a 3D printer, don't wait. Do it now. Like your window is, because here's the thing. Stratasys owns MakerBot now. Stratasys has the engineering. I mean, it's a good company. It's a great company. Yeah. And they have they put a lot of engineering into the new MakerBot line. It's going to be a solid line. So you're not going to see these. There's all these Kickstarters like, oh, here's a better MakerBot. It's not going to. There's no room for a better MakerBot, right? That window is closing. So if you've got an idea, do it now. The other piece of advice in terms of launching a product, just you better love it.
Yeah.
Right. And everybody who you talk to about it, or at least 85% of people, they should love it too. Right. If 5% of people love it, you're going to be in trouble.
Totally. What about, because I had the pleasure of meeting your team at SolidWorks World, and you seem to have brought together a good group of guys. So what would you say about bringing people together and finding, a graphics guy or a software guy? How about assembling a team? Any advice there?
It all goes back. It goes back to a couple things. First thing it goes back to is a product. If you have an idea and a business model that people can believe in, you can recruit an A team, which is what we did, right? And the second thing is, a lot of people have said it, and it's totally true. Everybody you should hire should be smarter than you.
Right.
Right. So we always, and we have, at least within our little group, the culture is always to look for people who are smarter than you, because we have way more work to get done than we can possibly do, right? And it's a good rule of thumb. Everybody says it. But you have to find the right people who will actually do it.
Greg, what will you be making in 5 years?
5 years from now? Probably parts for my race car, honestly. It's what I love. Probably aerodynamic parts for my race car.
On your Markforged 3D printer?
On a much bigger version of it. A much bigger version.
Excellent. Well, Greg, thank you so much for your time on the show today, and we'll send people over to markforged.com to check out the Mark I.
It was a pleasure, Simon. Thanks for having us.
This show is brought to you by the new Objet 500 Connects 3 from Stratasys, the world's only color and multi-material 3D printer. Offering incomparably brilliant and consistent colors, plus transparent colors, the Objet 500 Connects 3 lets you create the most true-to-life modeling possible. Find out more at stratasys.com. Thanks for listening in today, and if you'd like to be one of the first to use one of the Mark I 3D printers, they are currently available for pre-order at markforged.com. On our next episode, we'll be talking to the CEO and founder of the successfully kickstarted Robox 3D printer and micro-manufacturing platform. I'm your host, Simon Martin. Stay tuned and check in with us next time on Maker Galaxy.
A production of EBD Media.